Oh right, okay. I thought I'd show you this because I actually never did this. You know, this is how I do that make the packs, and when I'm reassembling them, it's important that to not have any short circuits. Now, one of the first things I'm going to do is take off any excess terminals that I don't require, because at this because I've done some 12 packs. This is a 6 pack because I've done some 12 packs where I've actually put two side by side, so you know there's these two here, and I've paralleled up another two. Let me just get two just to show you. Right, sometimes when I've got cells which are a good match, and the voltages are about the same and the charging rates are about the same, what I'll do is I'll pair them up. I'll put them in fours, and then I will, after I've done them in fours, now, but we'll continue with the sixes for now. I join them up. I wrap tape around them to hold them together, and then I'll glue them in the centre just to hold them so that they don't wobble about. But we'll just concentrate on doing the 6-pack for now. It's simpler. I'm going to take off the excess terminal, which I don't need because this is only going to be a 6-pack, so I'm just going to cut that terminal off. I can use that to bridge as the crossbar, or whatever you call it, the bus bar, I think, yeah, call it a bus bar, yeah. I'm going to take off this excess tape and insulation because I'm going to be needing that now, because there's a bit of terminal sticking over there. I'm actually going to leave part of that on just for safety, because I might actually use that tab. I'm going to leave it sticking up for now. I'm going to bend it over, but that might be useful to have there. So let me just stop this music thing, whatever's playing, because it's distracting. Hang on. I'll listen to my friend Joanna on there at the moment. Right, okay, now I'm going to separate the battery because the connections, make sure you don't short them between the positive and the ground. My scissors are blunt. I really need to get my cutters actually, because if you've got enough room, right, and I'll get my pliers and flatten that terminal there, bend it over for now out of the way because I might need that, and bend this one in as well so that we don't have any accidents. Lay that down. I've actually labelled them. A is 2 cells at the top of the pack, and then B is a middle pack, and C, which is the last 2 cells in the pack. The reason I do that is because often what I find out is that the cells at certain parts of the pack are usually weak. Now what I mean is, say for example the B pack, say that it was a weak pack because it'd been doing more work, and when I assemble packs of 12, what I'll do is stagger them. So in one pack I'll put the C where the B is, and the A where the C is on the other pack, if you know what I mean. Stagger them. So for example, let's pretend that this is there's 2 packs, and these are the cells from different packs. Let's just pretend for a moment, and I'll parallel them up. So if this pack was weak, rather than wasting it, I'll parallel up a strong pack with a weak pack. So we've got A, B, and then the next row, it might be C and B. So that way you can get more power out of make more use out of the energy, rather than, because the whole point, I'm recycling old packs, as I say, old batteries, and to save money. You see, even though these batteries no longer suitable to run the computer on their own, when you get enough of them, put them together, you actually end up with quite a substantial amount of energy conservation. I'm just going to show you, oh sorry about the noise, put my microphone over here. Now you remember I'm in the process of building battery pack 2. Now let's just have a look. I'm just going to take the lid off. As you can see, it's coming on really well. Let me just get the microphone, the camera, because it's hard for me to move the batteries. They're very heavy. Right, as you can see, I've got a lot of 12 packs in there. So this pack here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a whole pack, and that's a whole pack I made up. And this is a whole pack I made up. I can take them out. I've not glued them in. They should be, yeah, as you can see, they're quite loose. I can move them, slide them around. I haven't actually wired them all up yet, but anyway, that's just to show you what I'm doing. So I'm actually showing you how to build this 6-pack up. Let me just put this lid back on the tin for safety, so I don't drop any scissors on there and short on cords and see sparks flying around. The camera can go over there. The microphone can go over there. Right. Okay. Right. I'm just going to separate the next one. My cutters are really blunt. There we go. I've got it. Right. Now this is important. What I'm going to show you, because when you wire these up, the last thing you want to do is cause a short circuit. So I'm just going to. Now what I'm going to be doing, because this is just a 6-pack I'm doing up, the way I'm stacking them in my biscuit tin, as you know, I'm stacking them vertically. So I'm going to be putting, let's see, I'm actually going to be, because it's I'm going to be putting them together like this, and then I'm going to be wiring them. I'm going to have a wire between the negative on this end in series with a positive on this one, and then this one will be wired in series with the other pack. So what I'm actually going to be doing is, one of these packs will have to be upside down, so it's a bit of an odd number, 6s actually. Well, when I say that, I mean because it's I've only got 3. 3 is an odd number, so unfortunately one of these packs has to go upside down so I can get easy access to the negative terminal. Now it's important you insulate each pack from the other one, so you don't actually end up with a short circuit. So if you get a bit of blob of solder or something wedged between the batteries and you squeeze them together with tape, you can end up with a short circuit easily, because this insulation, this shrink wrap insulation, is very weak. It's not very strong. So what I do, I'll put these over here. I'm going to get the A battery pack. I've actually got where are we? Oh, that's an odd battery pack that's brought over. It's getting me confused. Right, what I do is I get some funky foam. This is insulation, and I'm going to cut a piece out of here. I'm just going to cut this up here. Right, I'm going to lay this on this battery pack, and I'm going to cut the back, the bottom to make it the right size, and I'm going to lay this, I'm going to glue this on here. Right, I'm just going to get a bit of glue, just ordinary general purpose adhesive. Actually I'll put the A on the outside because there is some gluey stuff on the other side, actually some double-sided tape already there, but it's not very sticky, so I'm just going to put a bit of glue on and then get my foam insulation and stick that on. Right, obviously that will dry. Get my next pack. I'm going to put the C pack in there. I'm going to stagger them anyway. I'll put some more glue on here on the other side of the foam, like that. Because the wiring comes last actually, so I'm going to put these on there and get another piece of foam. Let's see, insulation, I mean, obviously you could use any other type of material. I mean, heat-proof material is probably better, but I haven't really got the money to buy that. So this is going to be safe inside the tin anyway. I'm just going to cut that, just using my eye judgment. I'm not using a ruler for this because it's not that important. It's not something that has to be precision. I'm just getting a. It's not a precision job. This. I'm going to use the little pieces later, and then glue the other. Put some glue on the other side. It's just as I say, it's ordinary contact or adhesive. Put this other foam on the battery, insulation. You could use shrink wrap, I mean, if you wanted to do. I've run out of shrink wrap actually. Put some more glue on the other side. Right, this battery goes upside down because I want easy access to the negative terminal, so I'm going to turn that upside down so the negative's pointing upwards. Make sure nothing's going to short across while you're doing this. Obviously it might only short on one end, connect on one end. Now I've got that together, I'm going to get some tape. I'm just going to make sure that the batteries, I'm going to pull these connections out so I've got a nice flat surface again. I want a flat surface because I want to level it off, push it onto this flat surface to get it straight. I'm gonna level it that way because before the glue sets, obviously once it's set you can't get it lined up, and line it up again on this side, press it down. Hopefully we've got it level now. I can try that on the table. If I move my cloth a minute, I've got a table here, and just see if I've got it level. Seems to be. Right, okay. Now lay it flat on an insulating surface. Make sure it's not metal. Don't use a table, a metal table top or a steel tray. Avoid anything metal. Use insulation, cardboard or something like that. Right, okay. I'm just gonna get my tape now, my sticky tape. Now we get our I'm just using packing tape actually, because I say the wiring comes last. Oh, you can never get the ends of these things. This tape is pretty strong stuff. Actually, I'll stop the tape. I'll stop the recording in a moment, and then I'll come back to this. Hang on. Right, okay. Now I'll turn the battery round. Get my tape. Oops! Oh, look at that! I went out. That would happen. I've got another one. Just a minute. It's fun. Oh dear. Right, this one's easy. Right, here we go. Now get the tape and put it on. I'm just going to hang it over the edge of the table. And oops, lay it on the other side. As I say, this, oops, not the camera, sorry. It's a bit fiddly as this. I'm actually going to cut this because it's hard working with this roll on the end. Now I'm just going to bring the tape, now pull it a bit of tension, because you've got insulation between the battery packs. I'm just going to put a little bit of tension on, not much, just to hold them together, and wrap the battery pack. As I say, you can use heat shrink sleeving, but this, I don't like heating them up, you know. If you use that stuff you've got to put a hot heat gun on them, and I just don't like the idea of exposing to all that heat. And these lithium ion batteries aren't very tolerant of a lot of heat, and that's one of the things that damages them, actually weakens them, and it ages them rapidly. There's a document on the internet. I really recommend you go and read it. It's um, the battery. I think it's called the Battery University or something. Go and look it up. And right, okay. And it's extremely useful to tell you how to handle lithium-ion batteries. Now this terminal here is a bit raggy. I don't like that sharp. It's very sharp and it could cause a short circuit. So, and I'm just going to cut that off. There we go. There's an insulation cord going around this battery, which is a good thing because you don't want a short between this positive and the case of the battery. So I'm just going to bend this, curl this up a little bit and then push it down. The reason I do that is so that the smooth curve is against the battery corner and there's no sharp edge pointing down towards the battery. Keep all sharp edges pointing up. So if you have a sharp, say for example this here, look, say it's got a sharp raggy end, right, just this is the negative pole, so it doesn't really matter so much, but just curl it out, twist it with your tweezers, then bend it back a bit so that the sharp point is pointing down, and if necessary cut it off, but then I'm just going to flatten it a bit because it's the negative side, so there's no sharp edges pointing inwards towards the battery. Make sure you do that because this, if you pierce these batteries with a sharp terminal, you could cause them to explode, and we don't want that. So as I say, now this is just a 6-pack battery. Now what we have to do now is wire them up. Now that's quite straightforward really. It's no more complicated. All what I do is I usually use the terminal which I took off the battery I cut off earlier. What I'll do is, because these are wired in series, what we have to do is this is going to be the positive terminal and the negative comes at the bottom here, and I'm going to run a wire between here down through this little, you know, in between the batteries, up through there. So let's see, get my little stick. So I'm going to run a wire down here. Oops. This is just a wooden stick. Down here, out the other side, I'm going to run the wire, and then I'm going to connect them in series. Now obviously this is negative at this end, so positive will on the here will feed directly to negative on here, right, and then this negative positive comes out here. This positive, there'll be a wire running between here, running down here through the other side, and the wire will connect to the negative. So, but make sure you don't cross connect them. When I say that, I mean I use this straw to demonstrate. Do not cross connect that way. You'll end up causing a fire. Batteries are wired in series, sort of like that. Not one battery cell wired cross connected. Directly shorted. No, don't do that. Yeah, it will explode. Or burn you, or the wire will get extremely hot at least, and it will probably burn your hands. Right, okay, I'm just going to stop that for now, and then I'll get my wire and start doing some soldering. I'll try and show you a bit. Right, I'm just going to show you this. Now it's important, as you can see from this battery, it has an insulation, extra insulation, to prevent this terminal here from shorting against the case of the battery, but this one, well, it may have insulation underneath, but I'm just going to be a little bit extra careful, because when you solder wires onto here, it's possible that the heat can melt the plastic underneath. So what we're going to do is we're going to add some insulation underneath the terminal. This is quite simple. Just get some of this. You usually get it in the battery pack anyway. Just get some insulation, cut it to shape, right, get some glue, and because it might not be sticky enough, lift it up, put a little bit of glue underneath. Let's see, not much, just a bit, just to hold that, turn it around, and oh, it's my glue's a bit gooey, it's not right. Now put that underneath like that, just for safety. Now the other side, obviously, let's see, that's alright, that's got insulation running under it already, so that's okay. Now the reason for that is, quite as I say, when we get the soldering iron, it's not actually turned on right now, the soldering iron's not on right now, but if we decide to solder a terminal wire to the centre, because to even the current through the bridge bar, then it's important that we don't take current just from one end really. But anyway, it depends on the level of current you're taking from the batteries, but I'd suggest you don't take more than an amp anyway per battery pack. I mean an amp as in current, in the present, you know, I mean these are about 4.4 amp hours, so you don't want to overheat them, because batteries tend to be, you know, the life expectancy is dramatically shortened by overdrive, taking too much. Now I'll just bend that over. I'm not going to need this terminal that's sticking out here. This is the negative pole, so I'm going to take that terminal off, because I don't want that, and because this is a negative pole, there's no risk of a short, so I'm just going to bend that against the casing. Anyway, I've got a piece of wire, and I suppose I'd better put my soldering iron on. We'll come back in a second. Well, what I was saying earlier about equalising current, well, these batteries, remember that I've got some huge battery packs, and there's no way I'm going to take a lot of current. Got some more blobs of solder I recycled earlier. No way I'm going to be taking, so I'm actually going to solder to this little bit of tab that I bent over here. I'm just going to tin my wire. So I've got the power of 4 blobs of solder. Or is it the power of 3? I don't know. Anyway, I'm just going to tin this. Right, I need to get some solder on this terminal that I bent over. I put some flux on there already to help me tin it. I'm just going to tin that. Hopefully my wire is long enough. I did measure this, so what I'm going to do now is I'm going to thread the wire down. I've tinned the other end of the wire. I'm going to thread the wire down this side closest to the battery. The negative terminal that we're going to be connecting to on the other battery, on this battery here, on the other side. And now I'm going to bend this wire over, solder it onto this terminal. It's actually a bit stiff because I've tinned it. I'm going to solder this onto this terminal here. I need to get a bit more on here actually. I recycled some solder actually. I want to get some silver solder, but unfortunately, because of my financial situation at the moment, as you know, silver solder is actually more expensive, so I've recycled some old lead solder from some old circuit boards. Well, I figure it's better off in a landfill site, better off than being in a landfill site to be put to good use, and I know it's not exactly very healthy. Now, I don't like heating this up for too long. Right, I think we've got it connected. It's not very good. It's quite a high melting point, this is actually, because I've used some old lead. Right, I'm just going to turn it over, get the other end of my wire, because this needs to go to the negative of this cell here, which is here. I hope my wire's long enough. It's probably going to bend a bit more at the other end. I'm just going to turn around for safety so I'm working to the right. Actually, I don't think my wire's going to... Oh yes, it will. This is the negative side. I'm just going to lift this tab up here. I would have liked to have soldered onto that tab actually, but we're working on the negative side. I need to bend this over this negative terminal. That's the reason I was talking about on the positive side. It's important that you insulate so you don't short the battery out. I'm just going to bend it over onto the negative. Now I need some flux. Quite hard. I need to get some more flux as well. I need a lot of things. Just can't afford it. If I can get this out. It's not crumbling up very much. I actually heat it up on my electric hot plate. I melted the flux down a bit because it was starting to get a little bit uneven. It was all over the place. Right, just get this so. Oh, come on. Right, just tin it on here. I prefer high melting point solder actually because there's less chance of it breaking a connection when things warm up, but hopefully things aren't going to warm up so much. Right, just trying to get my wire. This is the negative side. I don't like warming these batteries up much, to be honest with you. Right. I should have put a bigger bit on here. Let me just get some of my. I have got a bit of solder on a stick. Let's use some of this. There we go. Okay, that's connected. Right, I'm just going to bend that terminal over the top. Right, we're soldered underneath to the negative of the wire. I'll just bend that terminal over the top. I don't really need it actually. I'm going to cut that off because it's just going to, it might short something out. Right. And bend that over because it's the negative side. Right, so connected there. Connected the other side. Let me just put a bit of this stick solder on because its melting point's a bit high, easier. I'm having trouble soldering at the moment for some reason. Right, there we go. Maybe my fluxes had it. Right, that's that. Now we use the bridge bar for the other two because now that's in series with that that's so. Because this is wired down. Positive goes down the purple wire, comes out and connects to the negative on here, right? Okay, so that's in series with that one. Now all we've got to do is this is positive, this is negative. So the positive, negative on the other side, and we need to wire this in series with that. So what I'm going to use is this bridge bar. So I'm going to get a piece of this bridge bar, cut it to length, and I'm going to tuck it underneath and wire those two together like that. So this is what came off an existing battery, so I'm just going to cut this. Right, there we go. Right, now I'm just going to flatten it so that there's no sharp bit sticking up. And I need to tin this, so I'm just going to move my battery a bit. I need to tin this in my flux. I'll move it so you can see. Right, I've dipped it in my flux and tweezers on it. Oops, come here, it's moving around. Right, I've tinned one end. Now, I've got it nice and tinned one end, turn it around. I've got the other end tinned. Now I'm just going to, because these two are connected in series, I'm just going to tuck this underneath the negative. If I can. I think the wire's solder stopping me. Right. bring it back into view, it would help. Right, got my tweezers. Oh, drop my tweezers. I'm very clumsy these days. Right, I've just tucked it underneath there a bit. Get some more flux. Put a bit on the terminal and the solder. And oh, we need to be underneath here. I'm struggling a bit. Right. Don't forget, this has already got insulation underneath that terminal, so we shouldn't have a problem with that. But now I need to get some solder on my iron. It's rolling about. Can't see. Blob on my solder. Right. Now I'm just going to solder this here to that terminal, just gently for now. And now I'm going to do the other end, turn it round. See if I can get. I'll have to use a bigger bit next time. And get my little piece of wood. Now I've got a piece of wood because it doesn't take the heat away from the soldering iron, so I can push down and put a little bit of pressure on while I'm soldering just to keep it together, which is useful. Using a metal screwdriver, obviously it's going to make it harder to melt the solder. Right, okay, that seems to have soldered on okay. Right, so we've got a working battery pack hopefully now. So this should be wired in series. So if I get my meter, we should have 11.1 volts. Depends if the battery's fully charged. Right, put my meter on the side because, as you know, before I had some problems. But we should have 11.1 volts now. Roughly. Oh, 11.24. Okay, there we go. It's wired up correctly. Well, if it wasn't, there'd be fires and sparks flying around by now. So that pack is ready to put my big battery pack now. 11.24 volts because each cell's 3.7, and it's a bit more than that because it's been charged up a bit more than that. But so anyway, that's ready to go in. Just move my battery out, my meter out of the way. So there we go. That's basically how I wire these up anyway. Depends. I mean, obviously the blue wire could go in the centre maybe, but it's more risky. There's a better chance of me melting through the insulation. There was already a tab stuck out there, so I used that. But that pack now I can just leave it, let the glue set. Make sure it's still straight. By using a flat surface, I'll just let the glue set and put that in. But it's not much different really when I'm doing the 12 pack. It just means that I have to put parallel, using the bridge bars, use some parallels on there and the other side. So instead of just 6, we have 12. And I only do that when I've got a matching set, and because I've used all my matching sets now, this is an odd pack because the other 2 packs I've got, they don't match, so I'm going to use them separate as well and equalize them using resistors and diodes like I explained in my earlier videos. Anyway, I think that's enough for today. Oh, I don't know. Let me get all this box out of the way. Oh, come on. Right. I just wanted to add this. I made this alteration. I got this circuit off the internet. Oh, let me see if I can find the original one. Right, okay. Here's the original circuit. Oh no, that's not the original one. Damn it! Sorry. Hang on. Where are we? Oh, I actually modified that one as well. Right. Sorry. Ignore this bit here. I'm just going to explain. Oh, I've actually changed this one as well. Damn it. Oh. Right, let me just go back to the other one. Right, I made a change to it because it was originally designed as an under voltage cut-off circuit, so that to prevent the batteries from getting too low. And well, for lithium ion batteries, I don't know if you're aware of this, it's very important that you don't discharge them fully, and they don't behave in the same way that NiCads do. They're completely different. They have no memory effect. What I wanted to do was just to show you something. Let me just I'm just going to pause a minute and get myself sorted out here. Hang on, where are we? Okay, right, I found it. Here we go. Right, now here's the original one. I'll just get it right so we can see it. All these advertisements keep popping up in here. Now this is the original one. It's on a website. Let's see if I can show you the website. It's Extreme Circuits, on the Extreme Circuits website, and you need to search for low voltage cutout for 12 volt SLA batteries. Now this is the original circuit, and I modified it to, because it was originally designed to cut power off to prevent lithium ion SLA batteries from being too heavily discharged. Right, let's get back to my drawing. Now I'm still going to use that circuit, but I'm also wanted to prevent overcharge as well, because I'm using solar energy. So as you know, if the sun's if we get quite a few days of sunshine, the last thing I really want is for the lithium ion batteries to be overcharged, because overcharging them actually shortens their lifespan considerably, and because they don't have a memory effect, you can actually they actually like being charged a little bit, and then you can stop them, allow them to rest. So it's not, they're completely different to NiCads. You don't have to cycle them completely, you know, full charge, full discharge, full charge, full discharge. You don't need to do that. In fact, lithium ion batteries don't like that. If you discharge a lithium ion battery too much, you can do irreversible damage to the actual cell structure. Now what you need to do is website, let's see if I can find it. There's a website, it's called Battery University. You need to go here to Battery University, and you need to look up how to prolong lithium based batteries. It's quite a long article, but it's really worth reading. You need to read all of it to fully understand exactly the do's and the don'ts, and about the temperatures and the charge levels, because if you overcharge a lithium ion battery, it will actually reduce its life cycle considerably. I think it goes into that further down the page, but it's a very long article. I mean, look, there's a lot there, but most of them are comments actually, but I do recommend you go and have a look at that before, if you're going to do anything with lithium ion batteries. And this is very much the document you need. Sorry, I'm a bit tired. That's why I'm stuttering a bit. I've been sort of doing my circuit for ages, and I'm kind of falling off the log at the moment. Anyway, so this is the reason why I'm using this particular circuit, is to prolong prolong the battery life. Right, that's the original one again. That's my YouTube. Right, see if I can show you this. Now, basically all I did to change this was, oh, that's the original circuit, right. There we go, this is my modified one. Now, all I did to change this was to create a feedback loop. Now, normally when this transistor switched on, the actual output of the IC, I've changed using a TL082. It's a FET IC op amp. So when the output is high, it actually turns on this transistor. This MOSFET, and I'm using an IRF 2807. They're actually very high. They're about 60 amps or something. So it's ideal for controlling batteries. There's no chance of that failing as long as it doesn't overheat. So that's going to be clamped on a heatsink. Now, normally I believe they use a PMP, I think, is it a positive MOSFET, but I'm using the reverse. So this circuit actually works backwards, because originally it was an under voltage protection circuit, which is the reason for the reset switch. Now, because my circuit's working in reverse, the reset switch actually doesn't actually work when you expect it to. It actually switches the circuit back on again. In other words, the charged circuit back on again when you press the reset switch rather than turning it off. I think I've got it right way around. It's a bit confusing. But anyway, and I did change the transistor down here. I think the original transistor that was in there was a BC548. I actually changed that because I didn't have one, and I found out that the BC182L was, which I have plenty of those lying around, was perfect. It does the job. There wasn't many other changes I needed to make. I did change some of the resistor values a little bit because I've run out of 22Ks, and I found out it worked quite happily with 24Ks. So I had some 24Ks in there, and I actually put a 22K variable resistor in here, and the original value for that was a 20K. So I mean, you can bend the rules a little bit. Anyway, as I said, and I put this feedback loop here. Now, the reason for that is I didn't want the circuit to go into oscillation, as in, say the battery overcharges and it's receiving power from the solar panel, so it's being pushed high. Now, what would happen would be the circuit would cut the power off, and at that point the voltage would shoot up even more, and it would cause a bit of a discrepancy. So what I did, and if the voltage actually drops, say the battery voltage drops a little bit, say about 5 volts or something, and the solar power is dropping, and it drops below that voltage of the battery, I didn't want it to oscillate and keep on switching the circuit back on and off all the time. So I created a bit of a void, a bit of an offset. This is what this is, bias offset. So it basically created about 8 volt offset. So for example, the circuit would say trigger at 12 volts, just as an example. Say that the circuit cut the power off at 12 volts, and rather than it coming back on at 11.99 volts, it actually has to get down to something like 10 volts before the circuit will re-engage again. That's the reason I put that resistor in, but I just changed this configuration around here. Let me just zoom in a bit so you can see a bit better. Now you can just see it there in the middle of the picture. I'll just change that part there, where the 22K variable resistor 1 is. I'll just go to the original circuit and show you the original. This is the original circuit, and you can see the difference. And it also uses an LM358, and it also uses a MOSFET, which is an MTP3055, and I'm not using that one. I'm using a higher power, and it's also different polarity. I'm using the IRF 2807. or 7. So anyway, that, and I've changed it to lithium charge circuit where the output is on the drain of the MOSFET, whereas the original one, it was the load. So I've made quite a few changes there. But anyway, I just thought I'd update you on that. I better stop this because it's